Okay, good morning. This is James Nesbitt. I'm the director of the Cyber Senate, and this is the day 2 of the 7th Annual Industrial Control Cybersecurity Europe Conference. Welcome to all of our viewers this morning. Thank you very much for joining us. This morning we are going to be speaking to Andy Powell. He is the Chief Information Security Officer for Maersk. He joined Maersk in 2018 as the Chief Information Security Officer and is accountable to the CIO and CEO for assuring all aspects of information security and cybersecurity across all brands that form part of A.P. Moller-Maersk. Prior to joining Maersk, Andy was head of the cybersecurity business for Capgemini. Prior to that, for CSC, and in both roles was responsible for delivering cybersecurity solutions for clients across all sectors. Andy has spent much of his career in the UK Royal Air Force as engineering officer and served as CIO and CISO for the RAF and was head of cybersecurity defense operations for the UK Ministry of Defence. Good morning, Andy. How are you?
I'm very well, thanks, James. It sounds, when people read my CV, I suddenly realize how old I am, but thank you.
That's impressive indeed. Thank you for joining us this morning. We are going to dive a little bit deeper into some of the challenges that Maersk has faced. Your presentation this morning is on digital transformation, automating OT, operational technology, and some of Maersk's biggest challenges. So without further ado, we do have 35 minutes for this session, and I'm going to go ahead and hand this session over to you, and I'll guide you. So if you would like to give us a little bit more background into Maersk's automating OT challenges, and one of our first bullet points here is instrumenting on OT.
Yeah, no, thanks, James. I think before we start on the actual technical solution, we need to understand the business problem, and that's probably the critical lesson for all CISOs today. Why is it that we're having to increase the protection and the capabilities, cyber capabilities in this area? And the prime reason is that most businesses, like ourselves, are automating, but also, most importantly, they're looking at the industrial control systems, the operational technology, and they're saying, how can we optimize the use of these very expensive technologies? How can we ensure they run in the most efficient way? How can we increase their effectiveness? And to do that, we need data. You know, we need to extract data from these devices. We need to understand how the OT is operating and the industrial control systems are operating, and that then allows us to undertake, you know, the tweaks, as I call it, to make them better. Now, to do that, they're instrumenting their OT significantly. You know, they're placing IoT type devices all over the place. They're taking that data and they're pushing it through, often through cloud type solutions, so they can review the data. So they're looking at ways and means to extract data off those devices. So that's one business driver from our point of view. The second business driver is automation. So by that I mean we're trying to find ways to be more cost effective in the way we deliver services that have traditionally taken quite a lot of manual input. So for instance, you know, around operating cranes and operating trucks around ports and terminals, can we do that through automation? And if we do, we'll need to control the devices. You know, we'll need to control the cranes, the trucks, etc., through a remote control capability. And we need to protect that and understand how that operates. So the two drivers for us are protecting the IoT network that's been built to optimize and drive greater efficiency. And the second is how we deal with the cyber risks that come from automating many of our manual processes. So they're the two business challenges. And I guess the final point to make is none of us live in a world where everything's built beautifully from new. Very few of us have the luxury of a startup mentality where we can build this all in, utilizing all the modern technologies. Many of us are operating in a legacy landscape of capabilities that are very old. You know, so some of the OT and ICS equipment that we're instrumenting and we are automating is 10, 15, 20 years old. And we have to find a way to clearly to instrument and automate that, but at the same time, we have to find a way to provide cybersecurity around that as well. So to the fundamental question of instrumentation, it is about not only the instrumentation itself, but the landscape that instrumentation is operating in. It's a legacy landscape. So to give you an example, one of the controller devices in one of our cranes is a Windows XP laptop. Okay, and trust me, Windows XP, for those of you who remember it, is pretty secure because nobody ever used it. It was shit, by my language. And I shouldn't be saying that, but the reality of life is we operate with legacy equipment, which sometimes is inherently secure because of its very lack of utility. So, and in some other cases, would you believe we're facing devices which are operating systems that went out in the 90s. And we're having to instrument against that landscape. So it's not only the challenge of instrumentation, it's the challenge of developing technical solutions to actually create those interfaces. So the business challenge, those are the two business challenges, as I mentioned, but also it's the challenge of the legacy landscape. That's the third piece of the jigsaw, if you like, that you need to understand. So hopefully that sets the context, James, in what we're trying to do today.
Yes, thank you. Thank you. And there's obviously a lot of challenges around things like Windows XP and some of those technical solutions. One of the first thing that came to my mind was patching, but we could probably sit here all morning and talk about that. So in relation to your current situation with instrumenting OT, what challenges are you finding that you need that are prevalent and one of your primary concerns in automating and ensuring that this instrumentation is correct and working properly?
Yeah, so it's I think that before we go into the sort of the instrumentation and technical challenge, it's also the second piece we need to bring out is the strategy that you need to apply. Am I instrumenting everything? Am I applying a cybersecurity capability across all my landscape? No. We can't afford to. It's really, really expensive. So what are we doing is applying a strategic approach, which we call the bow tie. And we've done it in IT, and we're now doing it in OT. The bow tie approach is you get a balance of protective and reactive measures from a cybersecurity capability point of view. So cybersecurity capability is about a balance of proactive and reactive measures. So instrumenting and providing complete visibility can give you 100% protection if you get it right. It'll also cost hundreds and hundreds of millions of dollars, which is that the right investment? When in reality, some of the risks may not materialize. Some of the areas of your estate may not need to be instrumented from a cyber point of view. I mean, clearly it needs to be instrumented from an IoT point of view, but do you need to have full coverage from a cyber point of view? And the answer is, in the bow tie model, you might accept the degree of impact is so low if it were exploited that actually instrumentation is not cost effective from a cyber point of view. So from purely from that cyber perspective, we are balancing where we instrument based on business impact and, more importantly, safety of life. So as we talked about earlier, when you automate processes, one of the things we've got to look at is the fail-safe mode. And if the fail-safe is not good enough to protect life, then clearly we need to look at placing greater protection in those areas. So it is a balance of risk and ensuring that you get the right balance. And then you instrument against where you believe the right level of protection is required. And then you, as you say, where you can place reactive measures, what I call recovery type measures, you do. And that's very, very important in this space because we have hundreds of thousands of devices. All right, and that creates an exceptional level of activity, and it's not activity that you can fully protect against, if that makes sense. So you've got to then decide how is your business configured and how best to get that balance of measures. So once you've achieved that, the second step is then, okay, here are the areas that we need to build out our proper protective cybersecurity in. Here are the devices that we really, really need to protect and have some visibility, full visibility and control of. We then need to develop the technical solutions. And we're doing this through a series of archetypes or patterns. because, to be honest, to develop bespoke solutions everywhere would be difficult. So we've done a review of the range of technologies. To my joke earlier, you know, how many Windows XP controllers do I have? Well, if I've got quite a few, then I'll build an archetype, a standard solution to interface with a Windows XP type controller. If it's a sort of IEC standard device on one of my engines, and there's hundreds of thousands of these, then it's very simply to develop a single solution which we can then replicate across where we need to replicate it. But the biggest challenge is understanding the range of archetypes, if that makes sense, and developing a set of solutions by archetype and standardizing those patterns or security patterns for those archetypes. And once you've done that, and that in itself is a challenge, there are then going to be exceptions. So to my earlier point, we've identified maybe a process or a monitoring capability which is high impact if it were exploited. It also happens to use a very, very unique one-off technology, and therefore to develop a bespoke solution for that could be quite costly. But we've identified that it's a high-risk item, so therefore the investment's appropriate. Does that make sense? So having developed a set of standard archetypes, we then identify exceptions which are high impact, and then look at how we develop tailored solutions where we have to. But the idea of creating tailored solutions everywhere isn't sustainable. We can't do that. So that is the approach we've taken. We've looked at, as you said, a number of archetypes, and then looked at any exceptions we've needed. And to be honest, some of these technical solutions are quite difficult, because the other point I'd like to make is the standards in this space. In many of your forums, I've heard this conversation. The standards in the OT domain aren't very good, you know, from a general point of view. We've got a range of new IoT standards we need to bring in that need to be applied. All the controllers we have on these devices, we need to bring up to spec through a series of better standards, so we all know what we're dealing with. So there's a real challenge in this space, and until that challenge is solved, we as a community need to keep developing these archetypes and these unique solutions. But as the standards improve, clearly we can reduce the number of solutions we have to build. So to your very, very good question, I have to build too many solutions today. I'd rather not. I'd rather we standardize the approach around how OT and IoT devices are built in the first place. And that would allow our community a fighting chance of better protecting. Does that make sense? So we're still struggling with a legacy domain, but let's not continue to build legacy. So I cry to the community who are building OT devices and IoT devices today is get together and come up with some standards, please, and drive that forward.
Okay, thank you. At one of our last shows, we did have a member of the UK government join us that was looking at regulation and standardization of IoT devices, but it was for the consumer market. But it was the closest we could get into trying to identify what we might be able to use or borrow from that, you know, for Industry 4.0. Some interesting elements there. So one size doesn't fit all. In relation to this, and as a business, each business is having to identify its own risks and implement its own strategy based upon its architecture. And of course, you've probably got numerous locations throughout the world that you're going to be responsible for. And we have an asset inventory element there too, as well as knowing where all these devices are. I would imagine that's quite complicated. Thank you. And your next discussion, your next piece of this presentation was, or this discussion here, is on automation of process. Can you elaborate a little bit further on that, Andy?
Yeah, so automation comes in a number of flavors. I think it's important we clarify what we mean. There's automation of the business process that we need to protect from a cyber point of view. And then there's the application of automation in the cyber process itself, if that makes sense. So when we talk about automation, we've got to be clear what we mean. There are significant complexities, as I mentioned earlier, to automating a business process. So when you automate a crane and the process of offloading containers from a ship using a crane in an automated fashion, you've created an automation process which in itself is inherently vulnerable to disruption, as you can imagine. But also, because of the nature of modern threats, we ourselves on the cyber world, given the the vast range of devices and the vast range of processes need to also automate our response, if that makes sense. We need to build automation in our solutions, because the human being, as flexible as they are, cannot hope to cover the range of attack vectors and space that is now being created as we automate. So when I talk about automation, I talk about automation from two perspectives. I talk about the ability of cyber to work inside business automation and provide solutions to make that safe. And I also talk about we in cyber building automated solutions to enable we to do our job better. And so one of the things we're looking at today is two parts to this. And one example in the OT space is partners who provide the technologies that we use. We geographically, as you mentioned, operate in 120 countries today. We have business partners working with us in those locations, all of whom bring a challenge to how we work with them. Can I assess those partners manually in every country and consistently keep that up to speed? No. Do I need to automate how I assess the vulnerability of those partners? And these partners, by the way, could be anything from the original equipment manufacturer for an engine on a ship or a crane or in a location, right through to an actual business partner who drives the truck that takes the container out of the terminal. Either way around, all of those third parties represent a risk to me and to the business, and therefore I need to assess that risk on an ongoing and regular basis. So if you multiply the number of partners globally, we're talking thousands and thousands of partners that all at any one moment in time represent a risk to how we do business. And so let me give you one scenario. An original equipment manufacturer has a contract to maintain our engines, and they use remote diagnostic data to do that. They also need to sometimes do some urgent changes remotely through a remote access capability. That clearly, all of that is a risk. But these operations are happening on a rapid basis globally across a very large fleet that we're running. How do I, in the cyber community, monitor that? Not only monitor that, but constantly assess that risk. Do I do that, as I mentioned, manually, or do I use some form of automation? And the answer is the latter, or a bit of both. So I've got to automate as much of the monitoring and collection of logs as I can, but I then need to rapidly distill that so that there's a manual element to evaluating if there's a real challenge. And it's a balance we all face in the IT, the familiar IT environment we're in. We're monitoring the logs across our networks. But if you imagine an OT network, it is significantly more complex and significantly more points that we need to capture in terms of logs and data. It is exponentially, vastly different from an IT network, which means that the amount of processing is vastly increased, and therefore the automation of that is critical. And so some of the SIEM technologies, SIEM technologies that you see in the IT world aren't fit for purpose in the OT world, because they can't deal with the level of complexity and the absolute level of data that's coming in. So we're seeing clearly a development of these technologies already in the OT environment that are more suitable for the OT environment. Those automation of capture of data, distillation of what good looks like, and then flagging anomalies. And we need to automate that. And AI is clearly the technologies a lot of these SIEM technologies are using. They're using compare and contrast. What does good look like? And if there's abnormal behavior, it flags that. We then need to develop a process for manual interventions. Once we know enough about what the anomaly is, we can try and understand the context, and then a human being can make a decision based on what they see. But sometimes the decision may have to be automated. And we already see in the IT world, we use technologies called EDR type technologies already to do detect and respond automatically. So if they see an anomaly, an automated process kicks in to break the connection or to immediately isolate the capability. And the same level of technology needs to be built into the OT world. We need the ability to sometimes automate the response as well as the indicator. So, for instance, if we see an anomaly in the OT space, we need rapidly to sometimes make an assessment. We've got to stop that connection straight away before it creates harm, if that makes sense. There's a lot of work to be done in that space. And again, another cry to the vendors, the more we can do in this space to develop more smart automated technologies to make these sorts of rapid automated decisions, the better. We've seen the success of EDR in the IT world. All of us who use EDR type technologies in the IT world are crying out similar and better in the OT world, because to my point, I cannot manually monitor thousands and thousands of partners doing thousands and thousands of operations. I need some form of automation, but more importantly, sometimes where it's business critical, I need to have an automated cutoff like I do on an endpoint. So we need to do more to develop the maturity in that space. There are solutions there, by the way, before many of the audience jump up and down and say, I can do that, I can do that. I know they can. What I'm saying is I don't think we've reached the level of maturity in the OT space yet that we are seeing in the IT space, purely because it's more complicated, it's more diverse. And so the real cry here is please, 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 let's find a way to do this better, in terms of decision making, automated decision making.
Right.
Does that
right.
answer your question, James?
It does. It sounds like a massive task as well, and clearly you're having to identify your most critical assets and make sure that those are covered first. But then you have a plethora of devices across these networks that potentially running a little wild. So sounds like a massive challenge. And what do you think would be the best way to work with the community in relation to maturing this gap or bridging it?
The one cry here is, and I'm sure the audience, many of them, some have come from an IT background, some have come from an engineering OT background, and we need the best of both worlds, because, and I think I might have said this in presentations before, by background, I'm an engineer, chartered engineer. I started my career fixing radars for a living, so, I come from a hands-on engineering world. And I can see why the OT community who come from that engineering world are quite protective of what they're doing. They're saying, hey, I'm instrumenting this because it's a requirement, for my capability to be automated and monitored, et cetera, et cetera. Don't need you IT guys to come in and tell me how to do my job. The reality is that, of course, then the engineering has moved into a different realm now. We've moved into the convergence of IT type processes with OT type methodologies, and that cries out for a combination of engineers who know how the systems operate and IT people who know how some of the new and emerging technologies can be applied. And we need to find a smart way to do that. And what we've done is we've developed 2 bow tie models and 2 federated models. So we're basically saying, hey, you engineers, you own this space. We don't want IT guys owning this OT space. You guys have got to own the space. However, there are some standards that we need to develop together that we work to. And then we acknowledge that you've got processes that are different to IT processes. Processes that mean if I set up a firewall in the OT world, it has to have different policies on it than a firewall in the IT world, because you are doing very different operations. As an example, if you shift an engine, you have to disable the firewall, do a shift of the engine, reconfigure the engine, and then turn the firewall back on. But you're doing that quite regularly, okay? Whereas in the IT world, we don't. We have a policy that might change it every 7 or 8 days. Their policy might be having to change it every 3 hours or 5 hours. So we've got to accept that there's differences in the way the OT world operates through engineers operating their equipment that will place greater and different demands on the cyber monitoring and cyber capabilities we're operating. And so what we effectively acknowledge is that space is owned by an educated group of people who know the OT space, and the IT space is owned by those who know the IT space. And sitting above that, through this federated model, we look down and make sure that the 2 communities are working together, hand in glove. What we don't try and do is make one community run another, if that makes sense, because that way failure lies. So we need to acknowledge differences, but also acknowledge the need for cooperation. So we're building that federated model now. Rome wasn't built in a day, but it's a challenge. Engineers and IT guys love to do battle. those battles continue. But the communities have got to come together and work together and accept each has knowledge to bring and processes to bring. I think that's very important.
Thank you. Thank you. Yeah, we did a podcast yesterday and had a conversation on confidentiality, integrity, and availability versus reliability and safety. And a lot of this had come up: engineering, IT. How do we create a communication spectrum as such where these divisions can work more effectively together, where safety's input into all of this, how are they getting involved in the conversation? And that's also a panel session that we'll run on this day as well. But I can see where it very much crosses over, and we actually dipped into the whole discussion on predictive maintenance and what the impacts are and the challenges of these processes are, because predictive maintenance has a large role there too, which is a whole nother discussion. But you can see how all the synergies of these challenges are coming together to make kind of the perfect storm. So we applaud you for your success thus far in creating strategies for something of this nature. One of the last bullet points here of our discussion, we have about 7 or 8 minutes left, is controlling device identities. Can you elaborate a little bit further on that for us?
Yeah, it's a major issue for everybody, I think, today. The minute we started making devices IP nodes in our network, the minute we knew we had to identify those devices like a person. So, a person or a client, whether it's a client, whether it's a user, is a node on the network. Once we've made those devices a node on the network, we have to do the same. And there isn't a difference. A device like a person can be attacked. A device like a person can be exploited. A device like a person can be given levels of access, and those levels of access need to be controlled and managed. And you can only do that through a strong set of identity processes and a set of identity technologies. And I'm a big fan. I've been a huge fan of IDAM for a number of years because was the most underappreciated element of cybersecurity for years. It is probably the most important element of cybersecurity today in the digital world that we're transforming. The reason is identity is the new frontier, of our domains. It used to be the firewall and the big Maginot line that we built around our networks. That's gone. That's absolutely gone. So now the client, the user, the device is now the front line in our network. It is the point of exploitation in our network, and therefore what we must do is bring about control of that point in our network. And that comes in 2 parts. One is you need to create an identity process, a business process, where you validate the identity of that device. You ensure it's pucker big British word, but it's correct. It is the right device. It isn't spoofing you. It isn't it isn't something else. So, but there's a business process, and there's a set of business ways that we do that today with clients. They'll actually be applied in the device space. The classic 2 to 3 people validating the identity to start with the device. Once you've got that identity approved, you then need to manage that identity, and you need to do that through a tool. And you need to bring the right tool into the space to control the identity. To my point earlier, the identity has attributes. Those attributes need to be understood, and those attributes need to be controlled on the device itself. Just like a person's identity has attributes, a device has attributes, and all those attributes need to be understood and then managed. And you can only do that with the right tool. You can't do it in a manual way. Go back to my point. So identity, which is the new frontier on devices, is about having a business process to identify the device and validate it, and then having the right tool to enforce the policies around that device identity. But the policies are important as well. And this is where we all struggle.
Fire alarm?
Might have to edit that one out. It's the fire alarm test. Edit that out.
That's okay. It gives us a live feel in a digital world.
There you go. Just so you know that we still need to do that. So I guess what I'm saying is we need to take this seriously. Devices can't just be, oh, here we go, we've got hundreds of thousands of devices, that's a painful identity process to go through. No, it's not. Each device represents a threat to your network. Each device can be exploited. You need to understand, can that, is that particular device important? Clearly. And then you need to develop the policy around control of that device. And if that device has lots of access, if you give it lots of freedoms, then you clearly need to accept that's high risk. And therefore, you need to enforce the controls around that identity, like you would a person. And again, the technologies to manage those identities and access is no different. If anything, it's much more complex. So, we implement CyberArk today to control privileged access. Where's the equivalent technology in the device space that can manage the scale of device numbers and identities and access privileges that we're going to need to grant? And that's, again, a call to the world out there to say, hey, in the device space, and we're in this space today, where is my IDAM enforcement tool for policy that can control the privileges and access that device has, and do it dynamically? Because to my point earlier, those devices are constantly changing what they need to access any one moment in time. How dynamic is that? Where is the technology to help us do that and understand that? Is this another space for AI? But if so, what are the challenges around doing that? So, and again, I know people will be screaming at the webcast saying, hey, we've got that, Andy, we can do that for you. I'm sure they can. But what I'd like to see is a little bit more maturity in this space, a lot more maturity in thinking, a lot more maturity in understanding, and I need to see a lot more competitive products, that are competing in this space to deliver those solutions. But it's a great field to be in. It's an exciting space. Device identity and access control and management is the new frontier. It's the new space, as far as I'm concerned.
Okay. Thank you very much. Interesting. Certainly a big challenge out there, and a call to the community as well, to put the thinking caps on. And if you want to get in touch with Maersk, I know that Gary Pryor should be online today and helping out with some contact details and potential questions that'll be thrown at you that you can answer at a later date. I know you'll be busy throughout the day. So I just want to thank you very much, Andy Powell. That's a discussion with Andy Powell, the Chief Information Security Officer for A.P. Moller Maersk, discussing digital transformation, automating OT, and some of their biggest challenges, and a call out to the community as well as to what we need to do and some of the challenges that asset owners are facing today. Andy, thank you very much for joining us. That's all the time we have, but we greatly appreciate you taking the time, and wish you all the success in some of these automation challenges.
Thanks, James. Thanks very much.
Thank you, sir.
All right. Okay.
Thank you. Bye-bye.
Bye-bye. Cheers, James. Thank you.
Bye-bye.